Hello friends, welcome back to the channel. In this video, we'll discuss the different types of tests that are there in testing of hypothesis. I'll not be discussing the formulas of each type. We'll only discuss the test and the type of data that is needed for applying this test. Suppose we consider Mumbai as the population and I make a claim that the average height of the people in Mumbai is 5 feet 7. Now to test this claim, we cannot go to each and every individual in Mumbai and check their heights. So what we'll do is we'll consider a small sample from this population, and based on the analysis of that sample, we'll try to conclude whether the average height of the people in Mumbai is 5 feet 7 or not. So this is what we do in testing of hypothesis. Based on the sample analysis, we'll try to conclude for the population.
Before we start with our testing of hypothesis, let us understand the notations that we'll be using throughout the video. So mu represents the population mean. X bar over here represents the sample mean. Sigma represents the population standard deviation. S represents sample standard deviation. N represents sample size. Capital P represents the population proportion. And small p represents the sample proportion. We can calculate the sample proportion by using the formula x upon n. So how to identify which test we must use for which kind of data? So the first identifier that we will use is the sample size. So if the sample size is greater than 30, then we use Z test. Now in Z test, there are 4 types of Z tests that we can use. The first is the test for single mean. So in single mean, what we will have is we'll have only one sample. So the kind of data that will be available in the question is we'll have population mean, sample mean, we'll have either population standard deviation or sample standard deviation, and the sample size. The second Z test is difference of mean. So here we'll have 2 sample, and the kind of data that will be available to us will be x1 bar, x2 bar, that is sample 1 mean, sample 2 mean, sigma 1, sigma 2, n1, n2. The third type of Z test that we can use is single proportion. So here again we'll have one sample and we'll have the population proportion. Then we'll have X and N, from which we can calculate the sample proportion. Here the parameter Q will also be there, that will be 1 minus P, and the sample size N will be given. Test number 4 is for difference of proportion. So here we'll have 2 samples given. So we'll have sample 1 proportion, sample 2 proportion. Now if the population proportion is not given, then we can estimate that by using the formula N1 P1 plus N2 P2 upon N1 plus N2, and we'll have the sample size N1 and N2 given. All those 4 tests are applicable when the sample size N is greater than 30. Okay, next, if the sample size N is less than 30, then we use T test. So the first is single mean. So here we'll have one sample. So if the actual sample data is given, then we need to estimate the value of X bar and S, that is sample mean and sample standard deviation. The sample size N will be given and the population mean will be given in the question. Second is difference of mean. So in difference of mean, we'll have two samples given. So here we'll have x1 bar, x2 bar, sample means, s1, s2, sample standard deviation, n1 and n2, that is the sample size. Third is called pair t-test. So in this test also we have two samples, but this is applicable when the two samples are dependent, or you can say they are associated to each other. So in this case what we do is we try to convert our two samples into one sample by taking the difference. So our difference will be x1 minus x2. So we try to take the difference between the two samples and then we calculate the mean of the difference, standard deviation of the difference, and the sample size n. So till now whatever test we have discussed, there we were using mean as the parameter. Suppose we want to test our hypothesis with variance as our parameter. So in variance, if we have only single sample, then for single sample variance we use chi-square test. In this, the data that will be given to us will be the sample variance S square, we'll have the sample size n, and sigma square, that is the population variance. Second, if we have say two samples, then for two samples we will use F test. F test is also called ratio of variance test. So in this, the data that will be given to us will be S1 square, S2 square, N1, N2, and if the population variances are not given, we can estimate the values of sigma 1 square and sigma 2 square. This test are used when we want to estimate or we want to test our hypothesis with variance as the parameter. So when we are talking about parameter, there are different parameters that we use for doing testing of hypothesis, and we also have few tests which are non-parametric. So if you want me to discuss the difference between parametric and non-parametric, just leave a comment. I'll make a separate video for that. There are two more applications for chi-square test. We can also use chi-square test for testing goodness of fit. So what do we mean by goodness of fit is, if we have a sample given to us and we want to check whether the sample is satisfying the population trend or whether it is following a population trend or not, whether it is fitting the population, then that we can do using a chi-square test. And the other application of chi-square test is for testing independence of attributes. That is, if we have two attributes or two parameters given to us and we want to check whether these two parameters are independent or dependent, then we can use our chi-square test to test this. So for using these two applications, the data that will be needed is, we'll need the frequency data, that is, we'll have the observed frequency, OI. What do we mean by observed frequency is, if we are considering some experiment, then whatever experimental value we will get will be our observed frequency. For example, if we take say rolling of a dice, then the observed frequency, if I am rolling a dice 100 times and if I am getting 1 15 times, then 15 becomes my observed frequency. And we will need something called as EI, that is the expected frequency. The expected frequency is also called the theoretical frequency. So if we take the same example of rolling of a dice 100 times, then the expected frequency will be 1 by 6 into 100 for 1. For each outcome, the probability is 1 by 6. So the expected frequency will be 1 by 6 into 100. And the value of chi-square will be given by summation of OI minus EI square upon EI. So using this, we will get the value of chi-square. The important thing to note over here, when we are calculating the expected frequencies, the summation of observed frequency should always be equal to the summation of expected frequency. Expected frequency we can calculate with the help of prior knowledge of the theory that we have. But if suppose the data is in the form of an contingency table, that is, if we have say two parameters A1, A2 and B1, B2, and the observed frequencies are A, B, C and D, then for such kind of data we can calculate the expected frequency by using the formula, that is row total into column total divided by grand total. So we can use the formula for calculating the expected frequency as row total into column total divided by grand total. So this formula for expected frequency we use when we have two parameters. So if you look at this example, we have two parameters. One is parameter A, which has two categories, and we have another parameter B, which also has two categories. So here I am doing the experiment independence of attributes. So for this, when I want to test, I don't have any prior knowledge about the two attributes. Then I can calculate the expected frequency by using the formula row total into column total divided by grand total. The next test that we use is called ANOVA. Okay, before starting ANOVA, if you have stayed back, that means you are enjoying the video. So it would be nice if you press the like button and subscribe to the channel. Okay, so in ANOVA, we have two types of ANOVA, one-way ANOVA and two-way ANOVA. So when do we use ANOVA? So what we have seen is if we have two samples for testing, we can use Z-test, T-test or F-test, but when we have three or more samples. So when we have three or more samples, then we cannot use the prior tests that we have seen. So whenever we have three or more samples, then for testing such three or more samples, we use ANOVA. And what parameter we are testing over here is mean. So we check whether the mean of all the samples is same or whether there is any difference between the mean. So when we have three or more samples and we want to test mean, we use ANOVA. Okay, what is the full form of ANOVA? So it is called analysis of variance. So here, though we are testing for mean, but we use variance for testing the hypothesis based on mean. So I'll explain the difference between one-way ANOVA and two-way ANOVA with the help of an example. So suppose I want to check the quality of a product or say quality of tire. So company is producing three types of tires. One is low quality tire, the other is medium quality tire, and we have a high quality tire. So now if I have a sample of some tires of all the three qualities and I want to check whether the average mileage of all the three qualities, whether it is same or whether there is any difference between the mileage. So here I am testing the quality as my parameter. So when we test only one parameter, we use one-way ANOVA. So you can see we have three samples over here. One is low quality tire, medium quality tire and high quality. We have three samples and we are checking the performance of the qualities. So we are using our parameter quality based on the three samples. So here we are doing one-way ANOVA. Now suppose I introduce one more parameter, that is I'll collect the samples from three different companies. So suppose I have three companies C1, C2 and C3. So now I am introducing one more parameter company. So I want to check whether the tires given by the company 1, 2 and 3, whether the average mileage is same for all the three or whether there is any difference. So now here I am introducing one more parameter, C company. So I am testing two parameters now, quality as well as company. So for such examples, we'll have to use two-way ANOVA. So when we have only one parameter quality, we use one-way ANOVA. And when we have two parameters, then we use two-way ANOVA. So if you have got bored by looking at this video, how to use your boredom to your advantage, I have explained in this video. The link will be on your screen. So just go through this video. This is my another channel. So subscribe to this channel also. Thank you for watching the video.